Third time's the charm. Number lines, here we go. Integers. So integers are normal counting numbers. So 0, 1, 2, 3, 4. They're opposites and 0, right? This defines integers. The ones to the right are positive. The ones to the left are negative. And while this may seem rudimentary, I just want to make sure we're clear on those things. Okay, that's integers. From 0 on up is whole numbers. Okay, by definition, those are the numbers that we work with most often. Okay, when they say a set of whole numbers, they're saying all whole numbers. So they would do something that looks like this. And that, my friends, is a set of whole numbers. Positive numbers, negative numbers. If I asked you to graph something on a number line, you are identifying the location of a given number with respect to the other numbers, right? The result is a coordinate on the number line. We do coordinates on the coordinate plane too, don't we? Okay, for example, and these are mine, these aren't out of the book, I'm just trying to give you some stuff. So for example, if I called that A, you would probably tell me A equals -1/2. Best guess, right? And B, you would just say -3. The more specific you can be, the better, but don't get too squirrely about it unless it's obvious. Okay, so we've touched on integers, we've touched on whole numbers. Those of you that were here for elementary school, and I'm talking first, second, third, those teachers taught you the term counting numbers or natural numbers, and those would only be numbers that you can hold in your hand. Something, 1 of something, 2 of something, those are counting numbers. If you ever see that number. Now, all of these definitions that I've just shared with you are real numbers. And yes, there are imaginary numbers. Real numbers. So real numbers consist of whole numbers. So that's 0, 1, 2, ... Integers, which in addition to that also include negatives. Negatives plus whole. Real numbers also include fractional portions of any of those numbers. Which means if I said graph the set of real numbers, you would do something like this. Every single number that can sit on this number line is a real number. Okay? So real numbers are whole numbers and their integer negative components and fractions thereof. Okay? We talk about negative and positive numbers oftentimes when we increase something or decrease something. But we also use negatives and positives with respect to north and south, weight gain, them's fighting words. Let's talk about my example 1. Your book is available for you when you're home, example 1. Here's mine. So this is A, going 8 steps upstairs. Using a positive or negative number, how would you state going 8 steps upstairs?
+8.
Positive 8 is right. In contrast, going 8 steps downstairs, you'd say -8, right? Not too bad. Or north and south. Going north, you don't realize this, but that literally is how they describe it. Go north 6 miles is a +6. Go south 6 miles is a -6. Don't ask me why, that's just the way they define it. It's just natural. Up, down. You're back where you started. Huh?
Because you've gone up 6.
All I'm doing is saying, if I ask you to say go south 6 miles, you're going to say -6. Okay, that's all I'm teaching you here. But yes, if you actually perform that operation, you'd be right back where you started. Okay, last thing, letter C. Bank deposit of $10, +10. Bank withdrawal, right, removal, would be a -10. Okay? Positives and negatives are useful for describing circumstances. The next thing they want me to touch upon, and this is the last thing, is inequalities, I-T-I-E-S. Inequalities are statements describing a relationship. I know you're like, really? You're going to define this? Yep. Between two numbers or two expressions. And I'll show you what I mean by that here in a minute. Inequalities are statements describing relationship between two numbers or two expressions. So obviously 6 is less than 7, right? That is the first example. Two expressions might be 6 times 2 is greater than 4 times 2. Okay? It's also used in algebra a lot, and you'll see it when we start working with it. Graph the numbers from least to greatest. That's their example 2. We're going to practice that just to be sure, okay, that we know what we're doing, just so that you're completely aware of the relationship. Here's example 2. And yes, you should be copying this. I don't care how easy it seems to you. Graph. Here we go. Okay, there's your set to be graphed. Looks like we go as high as 3 and as low as -1.5, so I'm going -2, -1, 0, 1, 2, 3. 0 is here, -1.5. -2, 1, and 3. Stating the obvious there, those are the coordinates of the numbers that you were asked to graph. That being said, in order, least to greatest, because you'll get asked that, I know that's like old news, but in order, least to greatest, you would have -2, -1.5, 0, 1, and 3. So if you're asked and you're not sure, use a number line. It's kind of helpful. You're doing